Would have been cool if it was all recorded from the beginning, but okay. All right, so check this out. If we have this box right here, this is going to be the codes. Sensitivity is alphabetical order, is SEN. Specificity is alphabetical order, has the P, so it comes later. This one comes first, this one comes later. We make the box, and the arrow here is going to go like this. The arrow here is going to go like this. So what does this mean? This means that my true positive, so what I'm doing here is true positive. I pick up the box. Then I divide, basically. True positive divided by true positive plus false negative. Because I'm going this direction. So I pick up the box and put it on itself. I isolate it, and then I go with the arrow. So if it's specificity, let me put the information in the inside just so it doesn't get confusing for everybody. If it's specificity, I'm going basically true negative. I pick up the box divided by true negative plus false positive. I'm going this way. All right. Now, like we said before, if you're moving positive, you're going forward in life. So positive predictive value. Here the arrow is doing this. So it's a true positive. I pick up the box. Wherever there's a circle, I pick up the box. Divided by true positive plus false positive. Now, in life, if you're moving backwards, you're being negative. So negative predictive value. I do it the same way with the codes, basically. So it's going to be true negative divided by, remember, I pick up the box on this one. The circle is here. Divided by true negative plus false negative. That's how I'm calculating all these formulas here. Now, let's step it up a little bit. What if we're talking about likelihood ratio? This is another formula a lot of people tend to forget. So I'm going to show you the formula for likelihood ratio. Again, the whole idea is alphabetical order whenever you line up sensitivity and specificity. For some reason, when you line them up, it all makes sense. So what we're going to do is line them up. So what we do here is sensitivity goes on top. It's alphabetical order. Specificity goes on the bottom. This is the formula for likelihood ratio. On likelihood ratio, you put the 1 for whatever you want to solve. What do I mean? Positive likelihood ratio. The 1 is going to go where the P is. Remember, positive. Specificity is positive because of the P. So you put the 1 right here. So likelihood ratio formula would be sensitivity divided by 1 minus specificity. That's positive likelihood ratio. The 1 goes with the P because it's positive likelihood ratio. Let me see how you spell likelihood. Likelihood. Does that make sense? Now, how about for negative likelihood ratio? I set it up the same way. Alphabetical order. Sensitive. But now the 1 will go where the negative is. 1 minus sensitivity divided by specificity. That's for negative likelihood ratio. See what I'm saying? That theme is always going to follow. The negative for negative is like negative is also going to follow negative predictive value as well. We're going to mention more of that. But always remember, positive, negative, they match. Now let's look at another type of formula that people tend to have an issue with, which is relative risk. So I do remember one thing. Cohort studies. If you look at the these people are twins. They're family. So they're relatives, I can say. So whenever you're trying to solve something for cohort type of studies, you're doing uh, relative risk. Okay. What else? If we're looking at case control, case control, these people are not relative. They're different. They look different. Case control. So this would be when I'm trying to solve, I'm using odds ratio. They're at odds ratio. Okay, what else? I should also include the idea of, yes, well, I'm going to mention everything. I'm going to include the idea that accuracy, and this is the same code we see for aminoglycoside and vancomycin. My mind just copies the same mnemonics and uses them again and again because it relates to my brain. Remember, aminoglycoside and vancomycin, you have not nephrotoxicity, autotoxicity, and thrombophlebitis or teratogenic effects. This one is different though. Accuracy is the same as validity. They are the same exact thing. So if they ever ask you something about accuracy and validity, it means the same thing. Something that's accurate has validity. All right. Same idea when it comes to reliability and precision. Precision and reliability are the same thing. One of them has a P for precision and the other one has an R for reliability. They mean the same thing. So what does that even mean? All right. So if something could be not accurate but be precise and reliable. How would this be? Well, let's say I have a scale in my house and when I weigh myself, it says I weigh 500 pounds. It's not accurate. But let's say I weigh myself and let's say consistently I weigh myself for like a year. And let's say in reality I lost 10 pounds. The weight is saying that I weigh 490. I mean, it's not accurate. I don't weigh 490, but there is precision. There is reliability. I could rely on that weight for my fluctuation. When I lose weight, it shows me results of me losing weight. When I increase weight, it shows results of me increasing weight. So that measurement is not accurate, but it holds a reliable standard where I can utilize this measurement to see changes. All right, that's that. So then you have relative risk. So relative risk, let's take a look at this. The arrows in relative risk go with the R's. You see how you have an R like this and an R like this. So what do? In relative risk, we grab these two R's and we put them one under the other. So here, try to remember. You got two R's in relative risk. We are going to grab the R, put one under the other. So in relative risk, what you end up having is that this R is going to move forward. So here's the box. Got to use your imagination here. Here's the box. You grab these R's, right? Remember this box here? We're moving this forward like this. So we're doing this. So relative risk is A divided by A plus B. Remember, this is A, let's say this is B, C, and D. Divided by, you see this box in the middle? Divided by C divided by C plus D. That's relative risk. RR. RR. So I'll do it again if you guys didn't understand it. So we have the box here for true positives. Remember this? Let's say A B, C, D, relative risk is going to have two R's. So what do? These R's kind of look like an arrow. We move them forward. So relative risk will be moved here. And then you do this. So what do we have? The formula is A divided by A plus B. Then it has a division in the middle. Divided by C divided by C plus D. That is relative risk. And it's important you know it like this. I'll tell you why it's important. I'll tell you why. So before we move on, does that make sense, everyone? Does that make sense? Okay, good, 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 good. All right. So, okay, if that's the case, we also have something called attributable risk. Attributable risk. So, relative risk, we understand this. This one makes sense. Relative risk, a nice formula. But if we have to look at attributable risk, it's basically going to be very similar. You're going to have the same equation, except you are subtracting. So instead of this line here for subtraction, attributable risk in Spanish, I just remember this. I remember that in Spanish, subtraction means resta, it means subtract. So I remember it's the same as the other one. So it's like this to me represents that it's like a copy of the last one, the relative risk, but you have to do an R, so it's resta. You're subtracting. I know this one is going to probably be a little bit more difficult for everyone because you don't have the same kind of mnemonic. I had to go Spanish, I know, but it's all the same. And then you have resta. So resta means subtract. So you copy it, but you're subtracting. Instead of it having division, it's just straight up going to be A plus B. Instead, now you're subtracting. Does that make sense? Now, I'll tell you the next one, attributable risk reduction. So this one here, be careful with this one. This one is super tricky. Attributable risk reduction. This one is easy. This one is easy. ARR. Why? Because it's the same as attributable risk, except you reverse it. So ARR means attributable risk reversed. Same thing. All you have to do is reverse it. Right? Attributable risk reversed. And this one is attributable risk. And then this one is relative risk. So for those formulas, let me do it one more time so everybody understands. We mentioned relative risk. We said relative risk was just R, R. You grab the R. You're supposed to move the R forward. Oh, I don't want it. Doesn't want to move. All right, point is you move this R forward like an arrow. When you move this forward, of course, A divided by A plus B divided by, because of this line down here, C divided by C plus D. That's easy. That's relative risk. Then we said the attributable risk. It's basically relative risk, but subtraction. Spanish R is resta. So I remember A divided by A plus B, of course, subtracted by C divided by C plus D. That's resta. And then you have attributable risk reduction. Same as attributable risk, all you have to do is reverse it. Attributable risk reversed. That easy. That easy. Doesn't really get too much easier than this. That's how I remember. Oh yeah, okay, one more formula. Hold on. Number needed to harm. So number needed to treat. I remember this. Number needed to treat. Number needed to treat. Treat kind of sounds like 3. It's 1 minus the one that has 3 letters. ARR. Number needed to treat. Number needed to 3. ARR. 3 letters. Then, of course, we have number needed to harm. This is 1 minus the other one, which is AR. If you remember one thing, you could easily put default the other one. It's another one. So yes. This is not difficult at all. Those were all the formulas, that the main ones that you need to know. Those are the main formulas that you need to know. Any questions?
This was a good one. Thank you.
Yes. That's how we know it. That's how we mastered this. Now this gets a little deeper. I'm telling you right now, this can get a little deeper. The way you start to understand, you could start to understand things without even calculating them. If you keep doing biostats, you get to the point where you understand things without calculating them. How? I'll tell you. If I have something like an equation where, let's say, like in relative risk, let's say I have, well, let's say in sensitivity, let's say. Sensitivity, I tend to have the false negative in 2 places. So I tend to have the false negative as a numerator. Oh, hold on. I'm saying it wrong. Hold on. No, I tend to have true positive and sensitive. Sensitive, you have the arrow going like this. So true positive is what we're talking about. So I tend to have true positive in 2 places. I tend to have it as a numerator. And I tend to have it in the denominator occasion here. So I can say I'm greatly affected by true positives when it comes to the sensitivity. It greatly affects the true positive greatly affects the sensitivity of the test. I can say that just because true positive is being found in 2 places, right? In the numerator and in the denominator in that sense. So if I have a major increase of true positives, you have to then think to your head. If there's a whole bunch of true positives, it's going to be able to affect more the sensitivity. Does that make sense? So if you look at this on a graph and on a chart, you start to see now relationships between them on what's on the numerator. Whatever's on the numerator has a greater relationship to the total that we're looking for. So you're also going to see that whatever is on the numerator is also going to be on the numerator of positive predictive value. This gets deeper. I'm telling you right now, I have sat down with these formulas and gave you some deep thought. But yeah, you'll see that they start to affect themselves. But remember, all right, so yes, remember. these formulas basically are a great big part of biostats. There's other things in biostats as well. I remember I showed Mona another trick about having valid relative risk versus invalidating them. The idea of them passing through number one. Also, different types of errors. You have um, alpha error, beta error. Easy for you to remember. I remember beta error is a type 2 error. Type 2 errors are the bad ones. Bad. Why are they bad? If you have an error that's type 2 or beta, it's the worst type because you're telling someone, for example, who has HIV that he does not have HIV. And he can go out and infect someone. And it will kind of be your fault, right? Because you have told him that he doesn't have. Now, if you tell someone that they do have a certain disease, and then you tell them the good news that they don't have it, they will celebrate. If you tell someone that they don't have a disease, and then you have to tell them that they do have it, they're going to be really mad. That's how I remember type 2 is the second letter. It's a beta type of error. It's the worst type. It's the bad one. I want to avoid these errors at all costs. These are the worst type of errors. What else? Yeah, biostats has so much. Oh, odds ratio. I never mentioned the odds ratio type of uh, formula. In odds ratio, the formula is just so ridiculous. It's crazy. It doesn't even make sense. To me, it's like a math, but it's like a math anomaly. For example, there's people who want to know odds ratio. They you can just do this. You can just divide everything. A divided by B divided by C divided by D. Straight up. Or you can cross multiply. A multiplied by D, or D multiplied by A, doesn't matter, divided by B multiplied by C. Odds ratio is just crazy, and it gives you the same answer. For me, just to make it easy, I like the idea of just dividing everything. A divided by B, C divided by D, getting the answer that way. That makes sense. Just straight up divide everything. That'll give you the answer. Okay. What else? So you have to know definitions as well. You have to know the definitions of things. You have to know how to make sense of it. I have like little mnemonics for everything. Like uh they have hawking, they have a bias. What was the bias called? Starts with a hawk, I remember. Um Hawking, does that ring a bell to anybody? I remember that bias is that they're watching you like a hawk, so you're being watched. That way you're performing things a certain ways for a certain outcome. Bergson bias, I think Bergson Hospital. You're taking your patients from a hospital settings. That way it doesn't reflect the normal population. So let me see, let me get the name of this. Uh let's see. This is so there's different types of bias that you can equate. There's so many different types of tricks. Yeah, I would have to come prepared with the notes so I can give a good class on this. But this is just a tidbit of information when it comes to the idea of knowing your formulas. So I'm going to stop the recording there.